The first thing we want to look for is if there's any like terms we can simplify on each side of the equation. Now, if you recall, the equal sign functions like a big wall. We cannot group across the equal sign. So if you look here, I've got 2x plus 5, no like terms there. I've got 6x minus 7, no like terms there. There's nothing to group, so we move on. Now we've got to get all of our variables to one side and all of the constant terms to the other. So first, I'm going to move these things to the left. I want to gather every term that has an x in it over onto this side. I've got 2x over here already. We're going to leave it there. And I've got a 6x on this side. It's positive. So how am I going to move the 6x over the equal sign? Yes, Hassan. I'm going to subtract 6x. Because the 6x is positive and it's attached to the 7 by subtraction, we're going to take away 6x, and whatever I do to one side, I have to do to the other. On the right-hand side, 6x minus 6x is going to cancel, give me 0. So all I have left on this side is negative 7. On this side, I've got 2x minus 6x, which is what? I got negative 4x. And that plus 5 is still there. Now, I've got all my x's on one side. Now I want to go ahead and get all of the constant terms and coefficients onto the other side. So we're going to move what first? Yes, Hassan John. Yeah, we're going to move this positive 5 over by taking 5 away. I want to move any term that does not contain an x to the other side, and because this 5 is positive, attached by addition, we're going to subtract 5 on both sides. This side, positive 5 minus 5 is going to cancel out, leaving me with negative 4x equals, and I've got negative 7 minus 5. It is on, it was in the printer. I think Mikhail moved it. It's on that piece of, just on the stack of paper, just on the other side. Thank you, sir. Thank you, if you don't mind. Okay, forget it. Seriously, there's no staples on the second floor? Ed Myers doesn't have any? Seriously? But he keeps them secret and hidden. So someone went into his room. Love it. Or Myers forgot to tell Allison. Something happened. She's gone? Oh my gosh. Okay, negative 7 minus 5 is? Negative 12. So now we've got negative 4x equals negative 12. We got one more step to do. I want to isolate this thing for x. The negative 4 and the x are attached by multiplication, so we're going to undo that multiplication by dividing. If I'm multiplying by negative 4, we're going to divide by negative 4 on both sides, and we're going to get x equals what? Negative 12 divided by negative 4 is? Fantastic. To check, we can plug it back in. The check on these ones is going to look a little different. The check on these ones says, okay, well, I've got 2x plus 5, and I've got 6x minus 7. And we're going to plug our value that we think x is into both sides, and as long as it stays equal, we're good. So I want to replace my x's everywhere with this value of 3. So I'm going to have 2 times 3 plus 5 equals 6 times 3 minus 7. Let's see if this is true. 2 times 3 is? 6 plus 5 is? 11. And over here, I've got to do 6 times 3, which is 18 minus 7, which is, and because 11 equals 11, we're good. This value must be correct. Because we ended up with a true statement down here, this is correct. Okay, so that's one way you can do this. The other way is really just deciding to move these variables to the other side, and you'll see the difference right away. If instead I move all the variables to the right, what this thing is going to look like is what this thing is going to end up behaving like is this. I'm going to take away 2x from both sides. The 2 here is positive, so I'm going to subtract 2x on both sides. 2x minus 2x is 0, leaving me just with 5 on the left-hand side. On the right-hand side, 6x minus 2x is positive 4x minus 7. And now you can see right away, this first step is where the difference is. What is the difference in this line versus this line? Hassan Joe. Yeah. That and that are the differences. For those of you who didn't hear Hassan Joe, here the coefficient on the x was negative. Over here the coefficient on the x is positive. That is the only difference here. How you choose to move things around, if you choose to move them to whatever side has more of these things, or a larger positive value, you're going to end up with a positive coefficient. And in my experience, at least, ending up with a positive coefficient here on the x seems like the smarter way to go for a lot of students. I see more mistakes when we end up going over here. Minus signs just get dropped. What I would encourage you to try and do is keep this coefficient positive. So let's keep going. The rest of the question is exactly the same. I've got 4x minus 7. I want to get the x by itself. So we're going to move any term that doesn't include the x to the other side. So because this 7 is negative, we're going to add 7 to both sides. 5 plus 7 is 12 equals 4x. Now I've got 4 times x. So I'm going to divide both sides by 4. The 4's are going to cancel, leaving me with a single x. 12 over 4 is 3. And we got the same value we did before. I'm not going to bother checking it again. The result would be the same. And it shouldn't matter which way we go about doing this, whether you move everything to the left or everything to the right. Assuming you do the algebra properly, nothing should change. Cool? Comments, questions, concerns. So this is the only new piece. I mean, I could do more examples of this, but at the end of the day, nothing here is fundamentally different. I want you to try these 4. I'll walk around and give help where I can. Once you've done these 4, let me know. I'll tell you what the answers are, and then you can move forward with the homework that I'm going to assign. So try these 4. I'll walk around, take a look, make sure we're good. If you've done them already, great. Check your answers with mine. Let me know if you've got any questions. Had one before. Where did it go? Okay, Carson, here you go. Here's the pencil. I'm sure it's correct, but everything else. So on question C and D, that would be a really smart person. You can do it that way, but it's just going to make your life a little bit. Okay. So what do we got here? 325 negative 1 correct. What do we got here? 325 correct. Oh. Everything else you do is correct. Okay, so these are the values you're looking for. Whoops, where is it? And a bunch of you have modeled something in your attempt to solve these four that I want to bring to the attention of everyone. So there was two of you modeled this perfectly, and I want to show you how I would, how this would get dealt with. So you have 2y minus 4 equals 17 minus 5y. And here's what I saw one nameless individual do. They wrote it up perfectly. Yeah. 2y here is positive. I'm going to bring it over here with the 5y's. I'm going to take away 2y. I'm going to take away 2y. This is going to cancel. I'm going to get negative 4 equals 17 minus 3y. And now I'm going to take away 17. I'm going to take away 17. It's going to be negative 21 equals negative 3y. Divide by negative 3. Divide by negative 3. Y equals 7. Why not? I'm seeing some shaking heads. What's the mistake?
Negative 5y minus negative 2y equals negative 7y.
This right here should end up as a negative 7. That changes your answer to 3 equals y. But at the end of the day, this person, who shall remain nameless, did so many awesome things. Literally every other step was correct. They did the same thing somewhere else. So like, okay, well, I'm going to subtract again, and then negative 4 minus 17 is negative 21. If this is a multi-mark question, I mark this out of 2. This person's getting 1.5 or 1 3/4 out of 2. Because they've shown me, can this person do algebra? Yeah. What I want you to be able to do in this chapter is algebra. This is great. This really simple mistake here is not where I'm going to get you as far as how this thing gets marked. This is really well done. One teensy little subtraction mistake, especially when they showed me further on that that's the mistake they're not going to make. Perfect. Another example of the same kind of deal. This person, I think it was question C. 3y plus 7 plus 2y equals 2y minus 8. Okay, so the way I taught you guys how to do these questions, the methods I'm trying to show you how to use, what should be the first step here? Collecting like terms. This person did not do that. And in this question, a really kind of neat thing happens. This person went, okay, I've got a 3y plus 7 plus 2y equals 2y minus 8. If I take away 2y on both sides, boom, boom, it's gone. And I'm going to be left with 3y plus 7 equals negative 8. Elegant. I like it. So far, that's a great first step. Not what I recommend, but it works. And we're going to take away 7. We're going to take away 7. We're going to get 3y equals negative 1. Divide by 3, divide by 3. Y equals negative 1/3. Where's the mistake? Is there a mistake? Awesome job.
It's the same mistake as last.
Exactly the same mistake. Has this person shown me that they can subtract properly somewhere else? Yeah, right here. So a mistake like this, and especially if this person is like, okay, yeah, fractions are numbers too. My answers are allowed to be fractions. There it is. Again, this is a mistake that if this question's out of 2, that's maybe a quarter mark, maybe a half mark. Because this person has shown me other places, yeah, the subtraction can happen. They just made a simple mistake right there because they were going perhaps a little too fast. Didn't stop to check their work. Y equals negative 1/3 is, I mean, you're allowed to have fractions as your answers here. Same kind of deal. Okay? And especially now that we're into algebra, where there's a whole bunch of different steps, and one simple mistake at the beginning can seemingly derail you. I am not marking just looking for a final answer. I want to see a process. Is the process here good? Yeah, it's great. The first one I showed you, the process, great. At the end of the day, I would love this final answer to be correct, and that's the only way you're going to get all of the available marks, is at the end of the day, there are no mistakes throughout. But a simple algebra mistake is not going to penalize you that much. Okay, at the end of the day, I'm way more concerned about the method than if you can do negative 8 minus 7 in your head. That was a chapter 1 issue. Chapter 5, I think is what we're on. Yep, chapter 5. Way more concerned about the method. So your answers are, you can see them now on the screen, 3, 20, negative 5, and negative 1. If, as you're going, you are struggling to come up with these, let me know. I will happily assist. Questions C and D, you can make your life so much easier by grouping your like terms. Do you have to group your like terms to solve these things? No. Totally doable without grouping your like terms. Like here, someone said, well, if I take away the 4n, could I also just take away the n? Absolutely. Taking away 4n and taking away n is the same as taking away 5n. 4n plus n is 5, and you can group them and then take them away from the 3, and that would be over here. But if you group them first, perhaps you notice that if I have 5n over here and 3n over here, grouping them shows you I don't want to move them all to this side. Maybe I do actually want to move them all to this side. Keep my coefficients positive. So that's all. Matthias, put your phone away. I'm going to show you today. Pretty sure that's a phone. It was? Okay, cool. It is 8:40 for those of you who are looking at my broken clock. I am not going to go through the verifying because I think I've been modeling that since the very first lesson. We're going to leave this. The only thing I'm going to make a note on here is at the end of the day, because now we've got variables on both sides, if the left side of the equation is the same as the right side of the equation, your answer is good. I've been modeling this. I don't think I need to go through this all again. So what I'm going to do is I'm just going to get you, excuse me, to work on these things. There's a bunch of practice. Do I want you to do all of it? You've got lots of time. Let's do it. Why not? You know what? Maybe I will only assign a chunk of it again. So there's 20 on this first chunk. There's 20 questions. I'll get you to do odds there too. Will odds get you doing everything? I think odds will get you doing everything. Nope, they won't get you doing any of everything. Let's get you doing evens this time. 1 to 20, I want to get you to do evens, except I'm going to add number 11 in there too. Evens and 11. And then if you flip ahead, you got evens and 11, and this is a page here called the cryptic quiz. I would like you to do this page as well. That is the practice I want you to do. We'll save distribution for tomorrow. Yeah, we'll save distribution. There you go. Evens and the cryptic quiz. There are answers, again, upside down on at the end of the even chunk for you to compare with there. Comments, questions, concerns, let me know. Otherwise, that's what you're working on. Giver.